Okay, question number 29. In a Millikan's oil drop experiment, an oil drop is stationary between two parallel plates. Two parallel plates. Okay, it's an oil drop. A second oil drop of same density. Same density. It doesn't say identical oil drop. Remember, it's saying about same density. So, density is same. Okay. Between the same place has twice the charge and twice the radius of the first oil drop. The second drop has same density. It has a twice the charge, twice the radius. It's larger. The second oil drop will initially, what will happen to the second oil drop? Now you see, why should a oil drop be stationary between two parallel plates? Let me say, this is your positive charge plate. This is your negatively charged plate. In an oil drop experiment, in Millikan's oil drop experiment, what happens? So the oil drop has a mass m. So therefore, mg will be acting downward. But it has a negative charge. As a result of it, there is an electric force that acts upwards. And if these two balances each other, the oil drop will not move. It will just be floating there, right? Therefore, Fe is equal to mg for the first equation. Or maybe, how do you write Fe? Fe you can write as Q times E is equal to m times. This is what we have as the first equation. Now, let us use this equation and proceed. Now here what the next time what happens over here is that we are using a second drop, okay, which has twice the radius. Which means what? 2q times E over here. Okay, electric field is not changing because same potential difference over here between the same plate. That's what it tells. Okay, distance is not changing, voltage is not changing. The electric field with them does not change. 2q times E is equal to mass. How do I write mass? Mass can be written as volume multiplied by density, right? So what is volume? Volume is given by 4 by 3 pi r cube, right? And density, what is density? Density is the same multiplied by g over here. Now what has happened to the radius? The radius has become twice, right? So this should now become, I'll just erase this and write that 2r the whole cube. I'll write 2r cube the whole cube, which should now be equal to 4 by 3 pi r cube rho g into E over here. Okay. So therefore, now we have this expression over here. So what has happened here? In this particular thing, if you look at this is nothing but the volume of the previous drop multiplied by the density. So the volume of the previous drop, volume multiplied by density is mass. So therefore, here, so what has happened is it becomes mg. So this factor, so this has become 2qe. Which one has become 2qe? This has become 2qe, okay? And this has become 8 times mg. 8 times mg. See, when you had QE here, QE was balancing the mg. But here what happens is the electric force definitely has doubled, but the mg force has become 8 times more. So as a result of it, what can happen? This force is larger as this compared to this force, and then the particle will start accelerating, right? Therefore, it accelerates in which direction? Downward direction.